Welcome to a MidAmerican Energy wind farm. A wind farm is a power plant that uses the energy contained in prevailing winds to generate electricity. Humans have harnessed the power of the wind for thousands of years. The earliest known use of wind power was the sailboat. Approximately 5,000 years ago in Egypt, boats with sails traveled up and down the Nile River. Several thousand years later, in Persia, wind energy was used to power vertical axis windmills for labor-intensive tasks like grinding grain. In Western Europe, the windmill evolved from a vertical axis to a more efficient horizontal axis configuration. Later, the Dutch modified the windmill to pump water and reclaim much of Holland from the sea. The multi-vane farm windmill was invented in the United States during the latter half of the 19th century. This familiar rural windmill was used for pumping groundwater in small quantities to livestock water tanks. In the 1930s and 40s, electricity-producing wind turbines were built in the U.S. to provide electricity to farms beyond the reach of power lines. By the early 1950s, however, the extension of the central power grid to nearly every American household made these wind turbines unnecessary. A new market for wind systems, or wind farms, began in the early 1980s as climbing oil prices in the 70s and a new federal law encouraged the use of alternative power sources. As the cost of wind technology becomes less expensive, areas such as the Great Plains, Midwest, Pacific Northwest, and Northeast are now beginning to see greater wind farm development. Wind farms typically have dozens of wind turbines. Since a single wind turbine needs about 1/2 an acre of land on which to operate and approximately 40 acres of wind space, a wind farm may spread out over thousands of acres. Wind farms are built in areas where there are reliable and favorable wind speeds. Wind resource maps and measurements are used to identify the best location for a wind farm. Wind farms need to be located close to power lines that can carry the electricity to homes and businesses. Since wind farms are usually in isolated locations, electronic equipment remotely monitors information such as wind speed, the amount of power being generated, operating temperature, and the gearbox oil level. Monitoring each wind turbine identifies problems early to prevent breakdowns and save on repair costs. A wind turbine uses the natural power of the wind to generate electricity. Wind turbines sit high atop towers hundreds of feet above the ground, so the wind can reach them without being blocked by obstacles such as trees, hills, or buildings. A wind turbine experiences significantly higher wind speeds the higher it is above the ground. The more constant the wind speed, between 8 and 40 miles per hour, the more electricity that can be generated from it. Wind turbines are much larger than they may appear. The span of the rotor blades on some turbines is more than 300 feet. These rotor blades sweep an area of almost 75,000 square feet with each rotation. Inside the wind turbine enclosure, or nacelle, are the components that generate electricity. The process begins when the rotor blades turn in the wind and transfer the wind power to the rotor hub. The low-speed shaft connects the rotor hub to the gearbox, which sits between the low-speed shaft and the high-speed shaft. Gears inside the gearbox increase the shaft speed so that the high-speed shaft turns much faster than the low-speed shaft. The high-speed shaft turns an electromagnet within the electrical generator, which converts the mechanical energy into electrical energy. Cables carry the electrical current from the wind turbine generator down through the tower to a step-up transformer where the voltage is increased. The electrical power is then sent to transmission lines that carry it to homes and businesses. For a wind turbine to operate most efficiently, it has to adapt to varying wind conditions. Many wind turbines have a computer control system that makes adjustments when the wind changes speed or direction. The wind turbine control system uses an anemometer to measure wind speed. The system starts the wind turbine when the wind reaches approximately 8 miles per hour. If the wind blows too hard, the controller engages a brake to stop the rotor blades from turning to prevent damage. The controller also can change the pitch of the blades to control the power output of the turbine. The rotor blades pitch or turn slightly out of the wind and then back again as needed. Normally, the blades will pitch a fraction of a degree at a time while the rotor is turning. A wind vane connected to the control system detects changes in wind direction. The control system then signals motors in the yaw drive to keep the rotor facing into the wind. Normally, the turbine will yaw or rotate only a few degrees at a time as the wind changes its direction. If the turbine rotates continuously in the same direction, the cables may become twisted and damaged. To prevent this, a cable twist counter tells the control system to stop the rotor blades and untwist the cables by rotating the wind turbine in the opposite direction until the cables are unwound. Wind energy is a non-polluting and renewable resource. Wind energy refers to the electrical power that can be generated from moving air. The more constant the wind speed, the more electricity that can be generated from it. Wind is simply air in motion. Wind develops as a result of the sun heating the Earth's surface unevenly. When a cloud blocks the sun from heating the land beneath it, the air cools, forming an area of high pressure. As the sun heats another land area, warm air rises, creating an area of low pressure. Wind is caused by air flowing from the high pressure to low pressure area. Air over land masses heats more quickly than air over water. The warm air over the land expands and rises, and heavier, cooler air over water moves in to take its place, creating local winds. At night, the winds reverse because the air cools more rapidly over land than water. On a larger scale, the winds that circle the Earth are created as the sun warms the surface air near the equator, and the cooler air from the north and south poles moves in to take its place.